Welcome. Let us learn design of FET biasing circuit. Here are the designing steps. Step 1. Draw transfer characteristics using 4-point method. Step 2. Extend lines from IDSS value and IP value. A rectangular will be formed. Step 3. Draw diagonal through point VGS equal to 0 and ID equal to 0. Step 4. Mark the point where this diagonal intersects transfer curve as Q point. Step 5. Project this point on ID and VGS axis and note down IDQ and VGSQ. Step 6. Calculate RS as RS equal to VGSQ upon IDQ. Step 7. Calculate VDSQ from VDS mean and VDS max. Locate center point C as VDS max minus VDS mean upon 2. Then VDSQ is given as VP plus C. Finally, applying KVL to output loop, find out RD. If you are designing self-bias circuit, then formula is RD plus RS equal to VDD minus VDSQ upon IDQ. If you are designing fixed bias circuit, RD is VDD minus VDSQ upon IDQ. Let us have one example. Design self-bias circuit for N-channel JFET with given specifications. We will start with the solution. Step 1 is to draw transfer characteristics using 4-point method. The 4 points are calculated like this. When VGS equal to 0, ID is IDSS, that is 8 milliampere, point A. When ID is 0, VGS is VGS of minus 6 volt, point B. When ID is IDSS by 2, that is 4 milliampere, VGS is 0.3 VP, that is minus 1.8 volt. When VGS is VP by 2 minus 3 volts, ID is IDSS by 4, that is 2 milliampere, point T. So here we will plot now points A, B, C, D. Remember that IDSS is 8 milliampere and VP, which is VGS off, is minus 6 volt. So this is point A, ID equal to 8 milliampere. Point P, VGS off is minus 6 volt. Point C and point D. Let us draw all these points to get a transfer curve. Then extend line from IDSS and IP value to get rectangular. Then draw diagonal through point VGS equal to 0 and ID equal to 0. Then mark the point where the diagonal intersects curve as Q point. Project this point on ID and VGS axis and note down IDQ and VGSQ. So here, as you can see, IDQ is 3 milliampere and VGSQ is minus 2.3 volts. Then calculate RS using the formula given. Putting the values of VGSQ and IDQ, we get here RS as 0.766 kilo ohm, that is 766 ohms. Then for calculation of VDSQ, we are using the formula VDS mean as VP plus 1 and VDS max equal to VDD. Now from where this formula has come? For that, refer the drain characteristics for FET. For drain characteristics, we know that for transistor to work as amplifier, Q point should be located in the center of saturation region. Here the center point is shown. So The saturation region has two boundaries. One is VP and another is VDD. And that's why VDS max, the maximum voltage, is taken as VDD and VDS mean is taken as VP plus 1. Actually it is VP, but to add the safety margin we are taking VP plus 1. So center will be the center of these 2 points. So VDS mean here for this example is coming 6 plus 1, that is 7 volt, and VDS max is 20, that is VDD. So center point C is calculated as 20 minus 7 upon 2, that is coming here 6.5. Then VDSQ value is equal to VP plus 6, that is 6 plus 6.5 equal to 12.5 volt. Remember we are taking mod value of VP, so don't consider negative sign for VP because VDS value is always positive for N-channel JFET. Finally, applying KVL to output loop. Since we are designing self-bias circuit, our answer for RD plus RS comes here as 2.5 kilo ohm. So subtracting RS from this value, we calculate RD as 1.734 kilo ohm. So here is the final circuit. So final step, draw the circuit for given biasing and write down the actual calculated values of RD, RS and RG, which we have assumed as 1 mega ohm. Thank you.